Hello and welcome to this video for Chapter 1 of Basic Sentential Logic, Informal Fallacies, and Cognitive Biases. In this video, I'm going to be talking about material that corresponds roughly to sections 1.2.1 and 1.2.4 of that text. It's out of order because sometimes it's just easier to explain things in a different order verbally as opposed to in text. So in this case, that's the order that I'll be going in. The topics are argument form, atomic and compound statements, statement operators, and also recursion. But first, argument form. So an argument, as I mentioned in the previous video and the video before, is a set of statements. And so accordingly, an argument's logical form is largely determined by the logical form of these statements, the premises and the conclusion of the argument. Now, I say largely determined because there's a little bit more, specifically, which are sorting them out into premises and conclusion. But if you have the form of the statements, that's 95% of the form of the argument. So that means that what we are interested in is now looking at a statement's logical form, because if we can get that, that takes us almost all the way to the argument's form. Well, what's a statement's form? A statement's form, or logical form, at least in terms of the kinds of form we'll be talking about in this course, is determined by the atomic statements it has as components and the operators, if any, that combine those components. So what I'll be talking about next is what all of that means. So the first topic is going to be this distinction between atomic and compound statements. So a statement in general, whether it's atomic or compound, is something that makes a claim, and it's typically expressed with a declarative sentence. So it's not a question, it's not an exclamation or an imperative or anything like that. An atomic statement is a statement that does not have parts that are themselves statements, whereas a compound statement is a statement that does have parts that are themselves statements. These are rough definitions, but after we work through some examples, it should be clear. So let's look at this argument. This argument has two premises and one conclusion. First premise is either the rabbit ran down the left trail or the rabbit ran down the right trail. Premise 2 is it is false that the rabbit ran down the right trail. And the conclusion is the rabbit ran down the left trail. Now, this is an argument. It consists of statements, two premises, and one conclusion. Let's look at premise 1. Premise 1 is a statement, but it's a compound statement. If you look at it, you can see that it has parts, in this case two parts, which are themselves statements. And I've underlined them here. The first is the rabbit ran down the left trail. That's a statement. That could be true or false. That's making a claim. We also have the rabbit ran down the right trail. That by itself is a statement. But premise 1 is a compound statement because it has these parts which are themselves statements. And it's putting these parts together with this either or. Okay, we'll get back to that. Let's look at premise 2. Premise 2 also is compound because it has one or more parts that are themselves statements. In this case, the rabbit ran down the right trail is a part of it is false that the rabbit ran down the right trail. I emphasize this because sometimes students think that a compound statement has to have two atomic statements or two components that are themselves statements. And that's not necessarily the case. Sometimes it could have one part and still build up a larger part out of that one part, like premise 2 here. But that part is compound because it also has this, it is false that. And if we look at the conclusion, statement 3, the rabbit ran down the left trail. That's just an atomic statement. So what I've done here is I have color-coded the statements. And interestingly, if you look at this, the entire argument really only uses two atomic statements. The first premise takes those two atomic statements that I've coded in blue and red here, blue and green, and puts them together with an either or. Premise 2 takes the green one and just says it's false, and premise 3 is just the blue atomic statement. Okay, so hopefully that provides some intuitive grasp on this distinction between atomic and compound statements. We'll be looking at it in a lot more detail, but for now, just some sort of intuitive grip on the idea is enough. A compound statement is a statement that's built up from atomic statements with statement operators. Okay, so it's not just that if you have one or two atomic statements, you can kind of put them together or write them next to each other, and now you have a compound statement. There's specific stuff that's needed to put them together, and we're going to call these statement operators. And we've already seen a couple. So if you recall premise 1, put the two parts together, the two atomic statements, with this either or. And premise 2 used it is false that to turn the atomic statement into a compound statement. And I've illustrated that here. Premise 1 is using either or to turn these two atomic statements into a compound. Premise 2 is using it as false that to turn this one atomic statement into a compound statement. Now altogether we'll be dealing with 4 statement operators in this course. There's a 5th one for anyone doing the optional material. And the 4 we're going to be looking at in the regular core material is negation, which is often expressed in English as it is false that, or not, or just N''T. Conjunction, which is usually expressed with an and, but sometimes you can say both something and something. Disjunction, which can be or, either or, and there's other ways to express it as well. And conditional, if something, then something. And these are the 4 operators that we'll be looking at in the core material. First, I want to just give you an idea of how these operators work in natural language. So for instance, if we take these 2 atomic statements, John is at the party, there is pizza at the party. One thing I could do is I could use the negation operator, not, and I could apply that to this first atomic statement, John is at the party, and I could negate that and make the compound statement, John isn't at the party. I could also use a conjunction operator to put both of these atomic statements together and say there is pizza at the party and John is at the party. I could use a disjunction operator, either John is at the party or there's pizza at the party. We could use conditional. If there is pizza at the party, then John is at the party. So you see how these things work. To take, in this case, atomic statements and build compound statements from either 1 or 2 atomic statements. The next topic, and this will be the last topic in this video, is recursion. Now these 4 statement operators, and actually all of them, including the 5th one that's in the optional material, but we'll just talk about these 4. They are recursive, which means that they can take as input not only atomic statements, which were the examples I gave previously, but they can also take as input compound statements that are formed by statement operators. Now you're already familiar with this in a couple of ways. You're familiar with this. You're familiar with this with arithmetic operators. And so what I'm going to do now is just do a brief detour into arithmetic operators and remind you of how recursion works there, so that then when you see it working with statement operators, hopefully that'll make a little bit more sense. Ultimately, we don't really care about arithmetic operators. This isn't a math course. But hopefully this will make the topic of recursion easier to get your head around. So there's 4 big arithmetic operators: addition, subtraction, multiplication, and division that everyone's familiar with. And These arithmetic operators can be used to form compound arithmetic expressions from atomic arithmetic expressions, which are just numerals. So for instance, here's a couple of atomic arithmetic expressions, 5 and 3, the numerals. I can use these operators, addition, subtraction, multiplication, division, to form a compound arithmetic expression, 5 plus 3, 5 minus 3. Okay, and everyone's familiar with this. Now the point is that arithmetic operators are recursive, meaning that they can also operate on expressions or statements arithmetic statements that are themselves the product of arithmetic operators. So, for example, this is an example that I just gave, 5 plus 3, so this is a compound arithmetic expression. But now this can be input to another one, and I can get 5 plus 3 plus 4 times 9. So here this operator combined not two atomic statements, but two compound statements into an even bigger compound statement. And that whole statement could be input to another arithmetic operator. Okay, and as you know, this can just go on indefinitely. You could make arithmetic expressions of arbitrary complexity just by reiterating this process again and again. And the point is that statement operators work the same way. So here are 4 atomic statements. You pay me the $20 you owe me. You come to the party, I'll jack your ride, I'll steal your wallet. And we can put atomic statements together with statement operators. So I could say, if you come to the party, then I'll steal your wallet. So here I'm using the conditional operator to put together the second and the fourth atomic statement here. But notice I could also say something like this. If you come to the party and you don't pay me the $20 you owe me, then either I'll steal your wallet or I'll jack your ride. Now, if you look at this, what this statement is it's a conditional. We have an if and a then. So we have a conditional operator, but the two pieces that conditional operator is putting together aren't atomic. The first piece I've got here in blue, and the second one I have here in yellow. Let's focus on the first one, just in blue. You come to the party and you don't pay me the $20 you owe me. That is itself a compound statement. It's this conjunction. So now I'm going to use color coding to break it apart. We have this blue part, the conjunction and is in yellow, and then this green component here. And notice that even the green component is compound because it's got a negation operator in it. You don't pay me the $20 you owe me. The atomic statement would be, you do pay me the $20. So there's actually 3 levels of recursion in play here. Now the last thing I want to say about recursion is this. When I introduced the topic, I said that you're already familiar with recursion and in 2 different ways. And the first way was you're familiar with it through arithmetic and arithmetic operations, because everyone listening to this has done basic math where they've evaluated complex arithmetic expressions of the sort that I gave. There's another way in which you're familiar with this, which has to do with recursion in play with statement operators, which is this. You all know, everyone listening to this video already knows implicitly, subconsciously, how to deal with recursive statement operators. So when I first read this sentence, if you come to the party and you don't pay me the $20 you owe me, then either I'll steal your wallet or I'll jack your ride. Everyone listening to this knew exactly how to parse this out. They knew what the components were. You knew what the operators were. Now you may not have known that explicitly. This might be the first time you've heard the word recursion, seen it defined, first time you've ever heard about statement operators. But ever since you were 3 years old and were learning how to talk, you could understand the difference between and or, right? If your mom said you could have cookie and cake, as opposed to your mom telling you you could have cookies or cake, you knew the difference. And you could also understand recursive applications of this, right? Your mom might have said, if you clean your room, you can have cookies or cake. And when you were 3 years old, or maybe 4, I don't know, but certainly at a very young age, maybe even younger than 3, you understood what that meant. And you understood that because you could parse this recursive statement structure. This is something that's going to come up again and again because it's easy to listen to these lectures and read the text and think, oh, wow, this is some crazy, complicated, logical mumbo jumbo that logicians came up with, and now I'm supposed to learn this stuff. And in one sense, that's right. But in another sense, this is stuff you already know. So it's not new. It's not something logicians came up with, really. But you know it only implicitly or subconsciously. You haven't explicitly reflected on it. You don't have concepts to talk about what it is you've been doing since you were 3 years old. But in a way, this is stuff you already know. And so don't think of it so much as stuff that you're being forced to learn that other people just came up with. Think about it as a way of understanding yourself and a way of understanding a really important ability that you've had since you were 2 or 3 or 4 years old, even though you haven't really thought about that ability and you haven't really thought about what you were doing when you were exercising this ability. Anyway, that's it for this video. In the next video, we will continue on.